Welcome to Learner's Prep. In this session, we'll learn the concept of boats and streams. We'll solve the problems based on this concept. First of all, let us see the basic points of this concept. What is a stream? So, stream is the flowing water in a river is called a stream. Still water, water that is stationary and does not flow, that is called still water. Upstream, movement against the direction of river's flow is called upstream. So if we are a boat is going against the direction of the water, it is the upstream. Downstream, movement in the same direction as the river's flow. So downstream is in the same direction of the water. If the boat is traveling, it is a downstream. Downstream speed, if the speed of a boat in still water is x kilometers per hour and the speed of the stream is y kilometers per hour, then downstream speed is equals to x plus y kilometers per hour. So we add the speed of the boat in still water plus speed of the stream. That gives the downstream speed. S of D. Reason, while moving downstream, the boat travels in the same direction as the river's flow. So the stream helps the boat move faster. So the speeds are added. Similarly, upstream speed. If the speed of the boat in still water is x kilometers per hour and speed of the stream is y kilometers per hour, then upstream speed is equals to x minus y kilometers per hour. The reason is when the boat is moving upstream, the boat travels against the direction of the river's flow. The stream opposes the boat's movement, reducing its speed. So the speed of the stream is subtracted. Speed of the boat in still water. The formula is upstream speed plus downstream speed divided by 2. So this formula gives the speed of the boat in still water. So let us solve some practice problems now. Question number 1. A boat can travel at a speed of 12 kilometers per hour in still water. The speed of the stream is 3 kilometers per hour. How long will the boat take to travel 90 kilometers downstream? So we have to find out here speed of the boat in downstream. Speed of the boat in downstream. Speed in downstream. So the speed of the boat in downstream, what is the formula? Speed of the boat plus speed of the stream. Speed of the boat is 12 kilometers per hour. Speed of the stream is 3 kilometers per hour. So that gives us 15 kilometers per hour. This is the speed of the boat in downstream, 15 kilometers per hour. So we have to find out the time taken to travel 90 kilometers in downstream. So time is equals to 90 divided by 15. Distance divided by speed gives us the time. So 90 divided by 5. So 15 divides 90 6 times. 6 hours. So the time taken by the boat for traveling 90 kilometers in downstream is 6 hours. So option C is the correct answer. Question number 2. A swimmer can swim at a speed of 36 kilometers per hour while moving with the current of a river and 20 kilometers per hour while swimming against the current. What is the swimmer's speed in still water? So speed in still water, the formula is both the speeds you have to add and divided by 2. So speed in still water. Speed in still water. So the formula is upstream speed and downstream speed, both you have to add. 36 plus 20 divided by 2. That gives the speed of the boat swimmer in still water. 36 plus 20 is 56. 56 divided by 2. So you can cancel 2 and 56 28 times. So what is remaining here? 28. 28 kilometers per hour. So this is the speed of the swimmer in still water. Option C is the correct answer. Question number 3. A boat covers 16 kilometers upstream in 4 hours and 32 kilometers downstream in 4 hours. How much time will it take to travel 30 kilometers in still water? So both the speeds we have to find out here. Upstream speed and downstream speed, both you have to find out. So speed in upstream is 16 kilometers divided by 4 hours, distance by time. So that is 4 kilometers per hour. So this is a upstream speed. Similarly, downstream speed 32 kilometers in 4 hours. So that is 8 kilometers per hour. So now we have to find out time taken. We have to find out speed in still water. Speed in still water is 4 plus 8 by 2. That is 12 by 2, 6 kilometers per hour. Speed of the boat in still water is 6 kilometers per hour. So what is the time taken to travel 30 kilometers in still water? So time is 30 kilometers divided by speed 6 kilometers per hour. So time is equals to distance by speed. So that is equals to 5. 6 divides 30 5 times. So it is 5 hours. So the time is 5 hours for traveling a distance of 30 kilometers in still water. Option B is the correct answer. Question number 4. A boat travels 12 kilometers upstream in 3 hours and 6 kilometers downstream in 20 minutes. How much time will it take for the boat to travel 33 kilometers in still water? Same procedure. We have to find out both the speeds, upstream speed and downstream speed. So only here minutes are given. We have to be careful here. So speed in upstream, distance by time. So that is 4 kilometers per hour. Similarly, downstream speed 6 kilometers by the time is 20 minutes. 20 minutes we have to convert into hours. So divide that with 60. 20 should be divided by 60. That gives 20 by 60 hours. So if you simplify this, 6 multiplied by 60 divided by 20. So if you simplify this 23 times, so that is 6 times of 3 is 18 kilometers per hour. 18 kilometers per hour. This is the downstream speed. So now we have to find out speed in still water. 4 plus 18 by 2. Both the speeds you have to add and divide by 2. So that is 22 by 2, which gives us 11 kilometers per hour. This is the speed in still water. So we need to find out the time. So time for 33 kilometers. So for 33 kilometers, time, divide this with speed 11 kilometers per hour. So 33 by 11 is 3. 3 hours is the time taken. for traveling 33 kilometers in still water. So option B is the correct answer here. Question number 5. A motorboat travels a certain distance downstream in 3 hours and returns the same distance upstream in 5 hours. If the speed of the stream is 4 kilometers per hour, what is the speed of the motorboat in still water? So in this question, the time taken for traveling in downstream is 3 hours and the time taken in upstream is 5 hours. So let us write down the ratio of timings. Ratio of timings. What are the ratio? 3 hours in downstream and 5 hours in upstream. So as we know that time and speed are inversely proportional. So let us write down the ratio of speed. Ratio of speed is inversely proportional. So inverse ratio is 5:3. Now speed of the stream is 4 kilometers per hour. So we don't know what is the speed of the motorboat. Speed of the motorboat, let us assume it as x. Speed of the boat, let us assume it as x. So speed of the boat is x and speed of the stream is 4 kilometers per hour. So let us find out upstream speed. Upstream speed is x plus 4 and downstream speed is x minus 4. X minus 4. So this is the ratio of the speeds according to our assumption and data given in the question. X plus 4 is a upstream speed and x minus 4 is a downstream, sorry, x plus 4 is a downstream speed and x minus 4 is a upstream speed. So according to the ratio which we obtained, which is obtained from the ratio of time, is 5:3. So that can be written as 5/3. So 5 parts is speed in the upstream, downstream, and 3 parts is the speed in the upstream. So that is equivalent to x plus 4 by x minus 4. So if you simplify this, you will get the speed of the boat, that is the value of x. So let us simplify this by cross multiplying. So what do you get by cross multiplying here? 5x minus 5 fours 20 is equals to 3x plus 3 fours 12. 5x minus 3x is equals to 12 plus 20. So that is a 2x is equals to 32. X is equals to 32 by 2, that is 16. So 16 kilometers per hour is the speed of the boat in still water. This is the answer, 16 kilometers per hour. This is the short way of solving this question. 16 kilometers per hour, option B is the correct answer. So now let us move on to the next question. Question number 6. A boat moves at 18 kilometers per hour in still water while the stream flows at 6 kilometers per hour. So in still water, speed of the boat is 18 kilometers per hour and speed of the stream is 6 kilometers per hour. So what are the relative speeds here? Speed in downstream, speed in upstream. Speed in downstream is 18 plus 6, that is 24 kilometers per hour. So this is the speed in downstream. Speed in upstream is 18 minus 6, that is 12 kilometers per hour. So the boat travels 60 kilometers downstream and returns to the starting point along the same route. What is the boat's average speed for the entire journey? So for average speed, what is the formula? Average speed, the formula is total distance traveled by total time. Total distance traveled by total time. So this we have used in the previous concepts. Total distance traveled divided by total time. So here the total distance is 60 in upstream and 60 in downstream. 60 plus 60, that is a total distance traveled. So total time. So time in downstream is 60 by 24. 60 by 24. Time in downstream. 60 by 24. That is equals to 12 5s, 12 2s. 5 by 2, that is 2.5. This is a time in downstream. 2.5 hours. Similarly, speed in upstream. 60 divided by 12. This is 60 divided by 12 is 5 hours. So this is the time in upstream and time in downstream. 2.5 and 5. So let us simplify this and find out the average speed. 60 plus 60 is 120. 5 plus 2.5 is 7.5. So there is a decimal in the denominator. So to remove the decimal, multiply both numerator and denominator by 2. 120 multiplied by 2 gives us 240. 7.5 multiplied by 2 gives us 15. 240 divided by 15. So if you simplify that, 15 ones 15, 9 remains, it becomes 90. 15 6 are 90. So average speed is 16 kilometers per hour. This is the average speed. 16 kilometers per hour is the average speed. Option D is the correct answer. Question number 7. A boat can travel at 10 kilometers per hour in still water and the speed of the stream is 2 kilometers per hour. The boat goes to a point upstream and returns to the starting point. If the total time taken for the round trip is 5 hours, what is the distance between the starting point and the destination? So in this question, speed of the boat in still water is given as 10 kilometers per hour and speed of the stream is given as 2 kilometers per hour. So now let us find out speed in both the cases, speed in downstream and speed in upstream. Speed in downstream we have to add and stream in upstream we have to subtract both the speeds. Downstream we have to add 10 plus 2, that is 12 kilometers per hour. Similarly, speed of the boat in upstream 10 minus 2, 8 kilometers per hour. So the ratio is 12 is to 8. 4 threes and 4 twos. This is the ratio of speeds. Ratio of speeds. Speed and time are inversely proportional. So ratio of time is the inverse ratio, that is 2 is to 3. 2 is to 3. So 2 parts is the time in the upstream. Sorry, the 2 parts is the time in the downstream and 3 parts is the time in the upstream. These are the timings. So, but the total time is given as 5 hours. So 2 parts plus 3 parts, 5 parts. So 5 parts is equivalent to 5 hours. And 2 parts is equivalent to 2 hours. 3 parts is equivalent to 3 hours. So 2 hours is the time is the downstream. 3 hours is time in upstream. So here the question is to find out the distance. So distance is equal to speed into time. Speed into time. So you can multiply upstream speed with upstream time or downstream speed with downstream time. So here upstream speed is 8 and upstream time is 3 hours. That is equals to 24 kilometers is the distance. Or you can multiply downstream speed also, downstream speed with downstream time, which is equals to downstream speed is 12 and downstream timing is 2. So here also it is 24 kilometers. In both the ways you got the same answer. 24 kilometers is the distance. So option C is the correct answer. Question number 8. A boat can travel at 15 kilometers per hour in still water, while speed of the stream is 3 kilometers per hour. A person rows the boat to a destination upstream and returns along the same route downstream. If the upstream journey takes 2 hours more than the downstream journey, what is the distance between the starting point and the destination? So first of all, we have to find out the speeds. Speed in upstream, speed in downstream. Speed in downstream is 15 plus 3. Still water is 15 and stream is 3. 15 plus 3 is 18 kilometers per hour. Similarly, upstream is 15 minus 3, which is equals to 12 kilometers per hour. A person rows the boat to a certain destination upstream and returns along the same route downstream. Now let us find out ratio of timings. Ratio of speeds we will find out first. Ratio of speeds is 18 is to 12. That is 6 threes and 6 twos. 3 is to 2 is the ratio of speeds. So now tell me what is the ratio of timings. Ratio of timings is the inverse ratio. 2 is to 3. 2 is to 3 is the ratio of timings. And in the question, it is given, in the previous question, it was given the total time. Here, the difference of the timings is given here. Upstream journey takes 2 hours more than the downstream journey. So the difference of the timings, 3 parts minus 2 parts is 1 part. So this 1 part is equivalent to 2 hours. So 1 part is equivalent to 2 hours. 2 parts is equivalent to 4 hours. Similarly, 3 parts is equivalent to 6 hours. So 4 hours is time taken for downstream journey and 6 hours is the time taken for upstream journey. So again here also we need to find out the distance. Distance is equals to speed into time. So either you can take upstream speed and upstream time, or both downstream also you can take. So upstream speed is 12, upstream time is 6. 12 6 is 72 kilometers. This is the distance. Or you can also take both downstream also, speed in downstream, time in downstream. So what are the speed and time in downstream? 18 and time in downstream is 4. 18 multiplied by 4, that is also equal to 72 kilometers. So in both the ways You got the answer as 72 kilometers is the answer. Option C is the correct answer. Question number 9. A boat takes 4 times as long to cover a certain distance upstream as it takes to cover the same distance downstream. What is the ratio of the speed of the boat in still water to the speed of the stream? So in this question, only the timings are given here. Boat takes 4 times as long to cover a certain distance upstream as it takes to cover the same distance in downstream. So that means time taken in upstream and time taken in downstream. So they are in the ratio of 4 is to 1. So time in upstream is 4 times, then the time in downstream. 4 is to 1 is the ratio of the timings. So here also we have to find out the inverse ratio. Same as the previous questions. Speed in upstream is to speed in downstream. So that is equal to 1 is to 4. Inverse ratio we have to find out. Speed in upstream is to speed in downstream. So what is the speed in upstream? Speed in upstream is speed of the boat in still water plus speed of the stream. So let us assume the speed of the boat in still water as B, speed of the stream as S. And if you subtract, you will get the upstream upstream speed B minus S. Similarly, if you add speed of the boat in still water plus speed of the stream, if you add, you will get the speed of the boat in downstream speed. So that is equal to 1 is to 4. That can be written as 1 by 4. So we'll simplify this and find out the ratio. So by cross multiplication, so what do you get? 4b minus 4s is equals to 1b, that is b, plus 1s, that is s. So on simplification, 4b minus b is equals to s plus 4s. So this is 3b, this is 5s. So b by s is equals to 5 by 3, which is equals to 5 is to 3. So this is the ratio of boat in still speed of the boat in still water is to speed of the stream. 5 is to 3 is the ratio of the boat in still water to the speed of the stream. Option C is the correct answer. Question number 10. A boat takes 7 hours 30 minutes to travel a certain distance upstream and 4 hours 30 minutes to travel the same distance downstream. What is the ratio of the speed of the boat in still water to the speed of the stream? Similar question. So only the difference is the time is given in minutes. So let us convert everything in hours. So time in upstream and time in downstream we have to find out. So first of all, 7 hours 30 minutes upstream and time in downstream is 4 hours 30 minutes. 30 minutes is half an hour. So half an hour can be written as 0.5. So time in upstream is 7.5 hours. And time in downstream, this is a time in upstream is 7.5 hours. Similarly, time in downstream is 4.5 hours. 30 minutes I have written it as 0.5 hours. Now ratio of time. 7.5 is to 4.5. So there is a decimal point in both the terms. after one digit. If you multiply that by 10, you will get 75 is to 45. By multiplying with 10, you will get 75 and 45. So if you can simplify it further, 75 and 45, both of them you can divide by 15, 15 fives, 15 threes. 5 is to 3 is a ratio of time. Now ratio of speeds, is the inverse ratio, 3 is to 5. So that is 3 is a speed in upstream and 5 parts is a speed in downstream. So same as the previous question, speed of the boat in still water is B. Speed of the stream is S. So B minus S gives speed in upstream and B plus S gives the speed in downstream, which is equal to 3 is to 5 and can be written as 3 by 5. Simplify this. So we write down here by cross multiplication 5B minus 5S is equal to 3B plus 3S. So both the B terms to one side, 5B minus 3B, 3S plus 5S, which is equals to 2B is equals to 8S. B by S is equals to 8 by 2, which is equals to 4 by 1. So that means the ratio of boat in still water and the speed of the stream is 4 is to 1. So that is the answer. 4 is to 1 is the correct answer. Option A is the correct answer. So these are some of the problems based on the concept of boats and streams. So we have covered almost all the models. If you come across any more models of questions, you can mention them in the comment box. So we'll cover them in the next sessions. Thank you.